Hello everyone. In this video, we're going to solve this problem where we're given a formula for the sum of these n terms here, and we want to find a formula for the sum of the reciprocals of these terms. But before solving this, let me give a shout out to Marvin Cato, who was able to solve this problem in our Facebook page. Let's get started. So let S sub n be equal to this one, which is the sum of a1, a2, and so on up to an. So our first step here is to find a formula for the nth term of the sequence, a sub n. And to find that, okay, if we look at the sum of the first n minus 1 terms, we see that the sum of the first n minus 1 terms will be equal to this expression. So this is the sum of the first n minus 1 terms, a1 plus n so on up to a sub n minus 1. Note that this sum here holds only for n greater than or equal to 2 because we're starting with a sub 1 and ends with a sub n minus 1. So when n is equal to 2, we only get a sub 1. So the first term of the sequence is a sub 1, which is of course equal to the sum of the first term. By substituting n equals 1, we get here 1 plus 6 plus 11 plus 6, so that is equal to 24. And now, for n greater than or equal to 2, we can already use both of this because these two expressions hold for n greater than or equal to 2. So we can get a sub n equal to the difference of this. Okay, so when we subtract this, cancel, 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 and what is left is a sub n. So we got here a sub n. So this is just the difference of these two expressions, and we'll get s sub n and then minus this one. So this is very easy to expand. So the expansion of this is n cubed minus a 3n squared plus a 3n minus 1. And then the expansion of this is n squared minus 2n plus 1 and multiply it by 6. You'll get 6n squared minus 12n plus 6. And then, of course, this 1 here, which is 11n minus 11 and then plus 6. And simplifying this difference, you'll get here n cubed minus n cubed, so that is equal to 0. And then you have here 6n squared negative 3n squared plus 6n squared. So that will give you positive 3n squared. And then you have here minus, so that is minus 3n squared. And then plus 6n squared, so you have here 3n squared. And then terms with n, so you have this expression here. So you have here 3n and then negative 12n and then 11n. So that is equal to 14n minus 12n. So that is 2n. So that is minus 2n and then plus 11n. So that is equal to 9n. And then the constant term, you have here negative 1 plus 6 and then minus 11 plus 6. So that is just equal to 0. So therefore, the constant term is plus 6. Factoring out the greatest common factor 3, we'll get here 3 times n squared plus 3n plus 2, which can be factored to n plus 1 times n plus 2. So therefore, the reciprocal of this is equal to, so you have here 1 over 3n, it is equal to this expression, and we can factor out this 1/3 here. And now by doing partial fraction decomposition for this one, so you can easily find this constant here by cover up technique. So what you can do here is you cover this one and plug in n equals 1 here. So you'll get 1 over 1, you'll get 1. And then to find this constant here, you just cover this 1 here and then plug in negative 2 for n here. And then take the value of this. So you have 1 over negative 1. So that is equal to negative 1. Therefore, this summation here from k equals 1 to k equals n. So that is equal to 1 over a1. So that is 1 over 24. And then plus, of course, summation from k equals 2 to n of our a sub k. So this is our a sub k. So just replace the n here by k. And this is a special series. Okay, so this is called a telescoping series. Just move this constant here in front of the summation, and we write down the terms of this sum here, and we'll get here when k is equal to 2, then this will be equal to 3, and then k equals to this is equal to 4. And then when k is equal to 3, this will be 4, and then this will be 5, and so on. And then when k is equal to n minus 1, you have here n, and then this will be equal to n plus 1. And finally, when k is equal to n, you'll get here n plus 1 and then n plus 2. And we can simplify this sum as, so this term cancel with that one, and then this cancels with the next term here, and then this will cancel out, and then this will cancel with this one. Therefore, the remaining terms will be 1/3 and then minus 1 over n plus 2. So therefore, we already have this closed form for this summation here. And we can simplify this and combine it into a single fraction. So performing some algebra, we'll get here 1 over 24, and then that is 1/3, combining this to a single fraction, and we'll get this one here, which is n minus 1 over 3n plus 6. And then again, combining this to a single fraction, so our LCD will be 24 times 3n plus 6. So we'll get here 3n plus 6, and then plus, you have here 8 times this one, which is equal to 8n minus 8. And the numerator can be simplified to 11n minus 2 all over this one. I hope you enjoyed this video. Please don't forget to like, share, and subscribe to help me grow this channel. Thanks for watching, and I'll see you next time. Bye bye.